Yeah, come on, everyone. Sure. So last class we have done maximum minima. Let's go ahead with integration. Before that, let's do one problem. Today is the deadline for the test. Hope everyone has given it. In case you have not given it, do make sure to give it. So we have a wire of length L. Is used to construct a sector. Meaning you have a wire of length L, you're planning to construct a sector like this. Getting it? Now you can construct different sectors. You can construct a thin sector like this, or you can construct a broad sector like this. You're getting it? So there are different sectors you can create. Basically, angle theta and radius r. You don't know both of them. So find the maximum area of the sector. How do we do this? Any answers? First thing, I am sure you guys don't know how to find the area of a sector. Think about it logically. Yeah? If you have a full circle, what is the angle theta here? 2 pi, right? So for an angle of 2 pi, the area is pi r square. So for an angle theta, what will be the area? Unitary method. This will be theta into pi r square by 2 pi. You can actually mug up this result. Area of a sector is theta r square by 2. Quite useful. I was recently teaching your seniors this thing. This area of a sector. Your seniors who are going to give the advanced exam this week. They had a more weird question though. There, area of a sector, theta r square by 2. Like that's like just a part of the question. This question was a deadly one. That's a different thing though. Now what to do? There, I think that is what is missing for you guys. Now you have the information. Now can you try? I'll give you a minute. Kaushambi, your cam is blank. Okay, oh fine. I can see you now. Sanya, I need to adjust your cam. Vihan, adjust your cam. Make sure your faces are visible, everyone. Devika, adjust your cam a bit. If you can see my face, I should be able to see your face. Simple. Let's get this. So what do you have here exactly? What you have is the perimeter, isn't it? See. So we have, this is the radius r. We have an arc length r theta, and we have one more radius r. That is your complete perimeter. So that is the length L, na? The perimeter is r plus r theta plus r is equal to L. So 2r plus r theta is equal to L. So what's the area? Area A is equal to theta r square by 2. Again, there are two variables here. So theta will be L minus 2r by r. Take this and substitute here. L minus 2r by r into r square by 2. One r will cancel. L minus 2r by r by 2. Lr by 2 minus r square. There, that's your area as function of radius. So you want to maximize this function. So dA by dr will be d by dr of Lr by 2 minus r square. This would be L by 2 minus 2r equal to 0. So we have r is equal to L by 4. We are done. Take this and substitute there. So we get A max when r is equal to L by 4. So you have L by 2, L by 4 minus L square by 16. L square by 16. Check. That's your answer. Clear with this, everyone? There. So that is like some of the things. And I can keep on asking more and more varieties of this, but I hope you got the hang of it. So there'll be always something given, constant, and they'll be asking something in terms of the same variable. So you have to create a maximum minimum like this. Any doubts on this? Did everyone try the sheets? Next thing, let's say. Got doubts in the sheets? Did everyone finish all the sheets or still pending? Still pending? Try to finish it off. Then we will discuss the paper cut, these doubts and paper cut doubts together on Wednesday. Next thing. Integration. This is more easy than differentiation, at least in physics. In actual maths, integration is a deadly one. I hated it when it is in maths. You get pretty deadly questions, but it's a pretty high weightage in maths. But for physics perspective, we really don't do much high level. But let's see. So again, let's start with something simple, which we already know, and then let's see from there how integration evolves. Let's say if you have a curve, let's say you have a straight line. This is x1, this is x2, and this is y. So if I ask you to find the area of this rectangle, it is simply the height y into breadth x2 minus x1, which can be written as y into delta x. Getting it? Now, this is for a rectangle. This though we know, we learned it in school. Now, what if you bring me a curve and you ask me to find the area? Let's say you have some random curve like this. Y is equal to f of x. I hope you remember that f of x is simply the function of it. Now I want to find the area of this curve x1 to x2. Now here the problem is when you say area under this curve, now understand we only know one formula, area of a rectangle is length into breadth. So this is the area under the curve, the shaded area is y into delta x. Now the problem here is this y changes at every point. In case of a rectangle, right, the height was same everywhere, so there was no issue. So what do we take y then? So we don't know the y. And this formula doesn't work. So what we do here, so this is the technique that we use. We take such a small dx. We choose a small delta x such that we can assume y is constant. Basically, we are approximating it. Let me show how it looks. Y is constant for that small thickness. So what we do is this. So when you have a curve like this, we will take such a thin slice. This is delta x. This is y. So basically at this point here, that is the y coordinate of it. So if I just exaggerate that figure, it kind of looks like this. So this is delta x. And we are saying this is height of y. And basically we are ignoring this part. So we are ignoring this. That's an error. And some here we'll say the area of this thin strip is y into delta x. Or you can say y subscript I. So basically at a distance x from here, at a distance xi, the height is yi. So these coordinates here are xi, comma, yi. I is a subscript, which is a variable. So this is the area of the thin strip. You're getting it? So now we are saying, so this is AI. So this AI is the area of the thin strip at distance xi. So for different values of x, we get different thin strips. Again, don't worry too much about this max part. I just want you to get the basic grasp of it. In Max, they'll do it in more detail. But actually, this is the basic thing. So we took a small rectangle of thickness delta x at a distance xi. So how does this solve our problem? So area under the curve would be sigma summation delta AI. So basically, we are adding up all these areas here, where I ka value goes from this x ka value goes from xi will go from x1, it goes to x2. So this is x1 and this is x2. This meaning of the symbol is summation, basically addition of all small pieces. I hope everyone knows this symbol ka meaning. Learned it in Max. In computer program, we call it for loop. Remember, for I is equal to 1 to n. We write the programming, right? AI. So I goes from A1, A2, A3, A4, so on like that. So basically, the meaning of this thing is when you take x is equal to x1, you took this rectangle. When you took x is equal to x2, you took this rectangle, this rectangle, this rectangle. Basically, you're adding all these rectangles. And when you add them, you're expecting to get area under the curve. But there's a problem here. This thing still has error. This is not accurate because you are neglecting the top pieces, isn't it? This still has error. Have a look at this thing here. So the main idea here is the only formula I know is area of a rectangle, which is length into breadth. And now you're suddenly coming and asking me find area under the curve, and I have no clue what the hell to do. You're getting it? So what we are doing is fine. I don't know how to find the area under the curve. So my suggestion is let's take such a small rectangle, right? The thin strip. It is not a rectangle, but I can approximate this to be a rectangle by neglecting this error and adding all these rectangles. So you know what you're doing exactly? This is what actually happens. And this happens every day. Right now, this is happening. When you're listening to my voice, this is happening right now. If you see an audio signal, so when I'm speaking, let's say this was the signal. This is called analog. I'm sure you must have heard about this thing, analog, digital. This is an analog. Basically, values are present at every time. Signal is present at all times. So basically, it's a continuously signal. It's a continuous signal. So to be more use technical words, it's a continuous signal. Okay. Now see, this is what happens. So when you speak, right, when you're listening to some voice or something, right now what you're hearing is not analog, you're hearing a digital signal, but you don't realize it. So what the computer does, आपने कभी देखा when you're watching this MP3 file, sometimes there is a file का पीछे ना, there is this thing, song का name, and then it is written 320 kbps, and sometimes it is written 128 kbps. Ever seen this thing behind the file का size? Whenever you're downloading songs or something MP3, you will find that file ka size there, 320 kbps, 128 kbps. You know what is that exactly? The meaning of this is when you say a signal is 128 kbps, let me show you how it looks. So this signal, let's say if I use a frame rate, now this is a digital signal conversion, okay? We're converting this analog to digital. I'll tell you what is the problem. If you tell a computer to record the signal, what will happen? It literally has to take every signal that is present. And how many signals are present? Infinite signals are present. So how much information you need? Infinite information you need. So how much data you need? Infinite data you need. Means your hard drive is not sufficient. You get in the problem? If you tell a computer to record every signal possible, you will get a huge data and you won't be able to process this. Itna kyun? For example, when these people write in movies, the songs they sing, they actually record it in a studio, right? Full setup and all. You know what is the size of that song file? That file goes almost to 20 to 30 GB. They record it with a very high, signal rate. Getting it? If you look at this thing, right? This movie you saw, kaun sa tha? Interstellar. That Interstellar movie that black hole which they showed, right? The actual file was 800 terabytes. Terabytes, huh? GB nahi hai. When they did all the calculations and they plotted the whole thing, it is 800 GB, 800 terabytes. Huge. Getting it? In the movie, what you see? पूरा movie का file आपको मिल जाएगा 2 GB में. You're getting it? So there is a big problem actually. This is one of the big issue. Whenever you're sending a file, if you can somehow compress it, and if you can put it, you are saving a lot of space. These are basically called compression algorithms. So if you are tomorrow into software, now this is the difference between a software engineer and a computer engineer. You know what's the difference? सबको लगता है same है. When you go to this computer science or software IT, both are completely different. There is a PhD in computer science. There is no PhD in IT. A computer science it is more of a research oriented, meaning, like I was saying, right? You will be creating algorithms, you'll be creating new functions. Whereas an IT engineer will simply use the functions. It's like, I hope you learned JavaScript, aisa kuch hai na? Programming C++ you've seen. An IT engineer, right, will use the C++ JavaScript and will use to create websites or whatever applications. Whereas a computer engineer will design that JavaScript. You're getting, he's more of a researcher. Like asking a question, if you ask him this question, right? If I have a 1 GB file, can you compress this into a 10 MB file? And when I retrieve it, I should not lose any information. This is what actually happens. Kabhi observe karke dekho. If you take a photo with your phone, let's say you have an Apple phone, take a photo, send that photo in WhatsApp and try to download it back. You won't get that quality. Because whenever that WhatsApp sends the photo, it will compress it into a low quality image because it wants to save space. And when you get it back, you won't get the same quality. So basically, WhatsApp is using a compression algorithm. Getting it? So this is what you do as a computer engineer. If you're thinking, right, computer matlab I'll go and just keep typing keys, nice try. Getting it? You are literally sitting there and thinking logically and trying to solve problems. So understand this 11th and 12th, you're getting a chance to learn like how to think, how to observe, how to analyze stuff using physics, maths, and chemistry. That is what you're actually learning here. So if I use digital compression here, and let's say I do this at a rate of 1 bit per second. You know the meaning of this? This is the meaning. See, every second I will take only one information, 1 bit. So my signal will look like this. So I'll take 1 bit here, 1 bit here, 1 bit here, 1 bit here, 1 bit, 1 bit, and 1 bit, and 1 bit. Now, if I play this sound, what will I hear? Something like this. Meaning you take that one sound and play it for 1 second, and then take this sound for play for 1 second and play it for 1 second. So if you do 1 bit per second compression, the signal will look like this. So this became a digital signal which you recorded at 1 bit per second. Basically, you can't hear anything, you won't understand anything. But if you go to a higher level, let's say if you go to something like 100 bits per second, meaning every second you're taking 100 pieces of sound. Now this thing will start looking like, maybe let me take it 10. I'm unable to draw. If you take a 10 bit per second, you will see something more little sensible. You'll see something of this sort. You're getting what is happening? As you make that signal, meaning as you're making thinner and thinner, smaller and smaller times, you will get better information. So this information, right, when you play this sound, you will hear something like, hi. You're getting it? The voice won't be clear. Maybe you will hear something like hi, because there is some signal there. Now, when you say 128 bits per second, you'll actually get almost a curve. So that is what you mean by this thing. So basically, the digital signals. So in audio files now, when you say 128 kbps, this implies you'll take 1,28,000 samples every second. Are you getting it? That means you're recording one signal at a rate of 1 by 1,28,000th second. So one signal is generated in this thing. So your width of the signal is this much. So when you say 320 kbps, you're taking 3,20,000 samples per second. Meaning you're recording one signal at a rate of 1 lakh, 1 by 3,20,000 second. So basically, every signal is recorded at this signal. So we take one signal at every 1 by 20th second. This is the time interval. So right now, when I'm speaking to you, my speaker is actually recording this analog into digital, right? If my headphones are pretty good, they will have a higher, good compression rate. Something like, I'm using Sony. I think this thing has I don't know the exact thing, but it should be more than 320 kbps. So it records that and sends it to an electric signal, right, to the Zoom call, and that comes to your speaker and you hear from there. So everything right now, your voice that you're hearing is digital. You're not hearing anything analog. If you go and play a violin, it is analog. If you play a harmonium, you play a guitar, it's a analog. The moment you record that and play the song, it becomes digital. Are you getting this? So this integration concept which I was teaching you here, taking small elements, we are actually using it right now. Best example, कभी आपने फोटो को zoom करके देखा? Suppose if I take something like this and if I zoom in and zoom in, I think this is the max I can zoom. You can actually start seeing here. So this thing, if you see, right, you can see the pixels there. You can clearly see the pixels here on my screen right now. So you know what you're doing actually? So if you ask a computer to draw a circle, you know what it does? So this is another sad part. In your life, you have never seen a circle on a computer screen or a TV screen. You know that? Forget about a circle. You have never seen a curve on your TV screen till now. If you ask a computer to draw a circle, you know what it does? Your computer screen has a lot of pixels. So when you ask it to draw a circle, this is what it draws. Computer doesn't know what is a curve. Ever seen this, railway station mein that numbers? 8 looks like this. 2 look like this. You don't get a curvy signals. Getting it? So what happens is your phone ka pixel density is so high. You ever played Snake ka game in Nokia mobile? Nokia ka snake kaisa tha? It's a rectangular snake, isn't it? So that is the thing. It is basically all pixels. So whenever you ask something to draw a computer this thing, right? So when it now this thing kind of looks like circle, but you know what you actually drawn? If you zoom inside, you will notice this thing is actually like this. A computer doesn't know how to draw a curve. It only knows straight lines, right line, left line, down, something like this. So this is what it does. It doesn't know how to draw a curve. Clear? That's what will happen when you zoom into a photo too much. You can start seeing pixels. The thing is, once you go beyond a certain level of pixel density, right? We are idiots, so we think it's a straight curve. So in your life, you have never seen a, you know what you call, you have never seen a video in your life. Everything that you see on a TV screen are photographs which are going pretty fast. Ever played with that Limca book? You know, the playbook thing, when you flip the book, flip book, it feels like some image is moving. So right now, what you're seeing on the screen is they're flashing around 24 images per second. So what you think is a video, but actually it is this thing. Why all that? You know, one thing, you have never heard your own voice. Did you ever record your own voice and try to hear your voice? You'll feel like, what the hell, this is not me. Ever tried it? If not today after the class, you take your phone, record your own voice and hear your voice. You will feel like, who the hell is this? And you show that recording to your mom and ask, Mom, is this my voice? You'll say, this is how you speak. Your friends, everyone will say that is your voice except you. You guys ever notice that? You see your own photograph, right? It feels weird. You show that photograph to your friend, they say, it is you. You know why you never heard your own voice? Record this and try this today after the class. You record your own voice and listen to it. It feels very hopeless. You will not believe that it is your own voice. Reason for others, right? Whenever you speak, the sound is directly going from your mouth to their ears. But for you, there's a problem. The sound is coming through the air. The sound is also traveling through your cheekbones. You're getting it? So your ear is receiving two different sounds. And you know, sound travels faster in solid than air. So the sound traveling through your cheekbones is faster than the sound traveling through the air. That means your ear actually hears two different sounds. So this is what it hears. When I say hi, how, what, doing, it'll hear two sounds every instant. Because there's a small lag. You will go mad. So what the brain does, it takes both the sounds and does a remix, and that's what you hear. And that is the reason, right? Sometimes you must have noticed your friend is singing a song, right? Or you're singing a song and you think you're singing so beautifully, and everyone else is looking like, pagal jaisa kyun, ga raha hai? Why is he shouting like this? Your voice will always look pleasant to you. Only the others will think like, what the hell are you doing? You must have noticed, right? You must have noticed it, right? Your friends are singing, they think their voice is super, but you think like it feels like stones are kept in a box and someone is shaking it. So happens. That is one. Getting it. And when you take a photograph and see it feels weird. Did you ever notice it? Your own photograph looks a little weird. That is because you always have a habit of seeing yourself in a mirror. So left and right are interchanged. You know it is you, but you'll feel kuch so weird hai. Maybe that pimple which is here, now it is here. Maybe that shade of color is here, it is here. And people, right, faces are not symmetrical. Someone will have one eye little big, one eye little small variations. Your hair is like this in the photo, the hair is like this. So you will feel the photo is like, this is me, but kuch to weird lag raha hai. But if you show the same photo to your friends, all will say it is you. Because that is how they are used to seeing you. You're getting it? So there, your whole life is a lie. You never heard your voice, you never seen a video, you don't even know how you look properly. You never seen a curve on a TV screen. So yeah, you should get an existential crisis right now. But okay, that is fine. That is where science comes. Clear this? So getting back to the story here. So basically every audio signal that we do, right? This is what happens in a digital. You're actually converting this. So what we're trying to do here is that the problem is that it has an error, fair enough. So somehow we need to sort this out. If the delta x tends to zero, the error can be neglected. So this is the whole story again. You make the rectangle so thin, we can almost neglect the error. So what you're suggesting is this curve which is there. So you're trying to draw it like this. That is how you're trying to draw actually. You're getting it? Now, if you make delta x very small, this is the scenario normally if you take delta x. So if you make delta x very, very small, you will get pretty nice one. Meaning basically you made it so small. Meaning it starts looking like a curve only. At least we won't be able to figure it out for our calculation purpose. So we are talking about a very thin slice. So this is delta extending to zero. Imagine the thinnest of the thinnest layer. Clear? So then the formula becomes something like this. So area under the curve is limit delta extends to zero summation delta ai, which is x1, xi goes from x1 to xi goes to x2. This is basically yi delta x. Now again, we are lazy people who will write this limit to sigma and everything. So we put one, this Snekker symbol, we call it integral. This function becomes y dx. And this limits will go from xi is x1. This is xi will go to x2. This is called the upper limit. Just understand, don't worry too much about the mathematical implication of this. The main idea here is that you're taking such a small element, you can make it a rectangle. So basically, the symbol sigma is summation. Integral also means the same thing. This symbol is integral. What it means is summation over sum of very small terms. That is the only difference. Delta x means change, dx means very, very small change. So mathematically speaking, there is no difference between sigma and integral. Only difference is when the moment you use the word integral, it is understood you're taking very small pieces. I hope is the concept clear, everyone. Clear? So whenever someone asks you what is area under the curve, Let's say this is y is equal to f of x. So this is area under the curve is integral y dx. Now, how to calculate that, we will see this. Now, it is not only for area, you can actually use it for different things. Okay? So we can actually use this for, later on we will see for work. Integral f dx. Getting it? You will have a lot of things like this. If you want displacement, so it's not always y and x, you can have any quantity, v into time. So like that, so on, we'll see all those quantities. But I hope everyone got the crux of this thing, what you're doing. So integration is basically dividing it into small parts and then adding it up into a small round rectangles. Great. Now, this integral is also called as anti-differential. Now see, if you differentiate an integral, this is a pretty neat idea there. Think about it. If you add something and if you break it, what do you get? You get the function back. If you add all the parts and then if you break it again, you will get the individual parts again, isn't it? So differentiation is basically breaking into thin parts and integration is adding all those parts. If you do both together, we'll get the function back. So when we differentiate an integral, we get the function back. Now let's see some results. Now in integration, right, there are only two levels. We don't have chain rule, we don't have division rule, we don't have all that. There are actually much more complex things, but physics mein itna chahiye nahi. So we'll just stick with two levels. You literally have to mug it up. So we'll not be deriving all those results. Clear? So let's see. The first one. The most common one, almost like 70% of your integrations are this only, x power n ka integration. So we have a function f of x, and then we have f of x dx. So the first integral, x power n. So integral x power n dx for n not equal to -1. So this formula is not valid when n is -1. This formula is given by x power n plus 1 by n plus 1 plus constant. This kind of integration is called indefinite integration. If you observe here, there are no limits here. There is no upper and lower limit. That means you're not telling me to find the area from where to where. You gave me a curve and you didn't tell me you want me to find the area from where to where. You want from starting to here, from here to here, exactly where to where. So there are no upper and lower limits. So in this kind of, so that's the reason we always have to put a constant here. So this is called indefinite integration. We are not sure what is the constant. So just understand that thing. If they don't give you limits, you have to put plus constant. Now let's try to understand this thing, okay? Just now we wrote the statement wrong, but if you differentiate a function, you should get the function back. So d by dx of x power n plus 1 by n plus 1 plus constant. This will be 1 by n plus 1 d by dx of x power n plus 1. This is 0. This is n plus 1 by n plus 1 x power n plus 1 minus 1. This is x power n. Did you see? So if I differentiate this result, I should get this back. Are you getting the logic here? That's what I was teaching you here, anti-differential. So this is a pretty interesting result. So see, this is how the question becomes. The question is, the answer for this integral When you differentiate, you should get it back. It's more like a puzzle now. I'll show you more examples on this. There, I was just trying to show you here. If you differentiate the function, you'll get the integral back. Example, if you say integral x square dx, then this would be x power 2 plus 1 by 2 plus 1 plus constant, because you didn't give me limits. That's how we write. Please note it down. Just note down this part, will do. Today we'll do the basics of integration. Next class will be applications. That will be deadly. That will be fun, actually. Copied?
Just a
Now, what if limits are given? Right? Just try to absorb this. We'll do a lot of examples that will make things clear. The same function, if someone gives you limits, integral x power n dx, limits are from x1 to x2. So limits are given here. This is called definite integration. Means you definitely know you want area from where to where. So how do we do this? It is the same formula, but listen carefully. X power n plus 1 by n plus 1. We'll put a straight line like this, x1 to x2. So this implies integration is done. Integration ho gaya. Yeah, the same formula. Now we have to apply limits. So the straight line indicates we have to still apply limits. Now let's try to understand. What did we get here? This is area under the curve. So if you substitute x2 ka value, so we put first x2 n plus 1 by n plus 1. So what is this? This is area up to x2. Then we put x1 ka value, x1 power n plus 1 by n plus 1. This is what area up to x1. Now subtract them. Then what do you get? So we have a curve here. You found all this area that is up to x2. Then you found here up to x1. Then you get area between them, isn't it? So this whole result, integral x power n dx, x1 to x2. Again, for n not equal to minus 1. If n is equal to 1, minus 1, we'll see what will happen. This is x2 power n plus 1 by n plus 1 minus, this is what you put. Put the upper limit, put the lower limit and subtract them. That is the idea there. So this is area between x1 and x2. That is how you apply limits. So the formula is same as indefinite integration. So first put the upper limit, then put the lower limit, because you do always final minus initial. And then subtract them. That will give you the area under the curve. Let me show an example how it looks. You can put on the blue thing. That would be your final thing, definite integration. This is more prominent. Indefinite we will use once in a while, but the thing with the limits we'll use it quite frequently. And like I'm saying, just try to grasp the basics. Don't worry too much about it. In Max they'll teach you this thing for 2.5 months. Entire calculus, they start from limits, differentiation, integration will go for 3.5 months. And it is a pretty high weightage in Max. And all these are nothing. Like right now, what we're doing is like a small puppy. They'll be teaching you Godzillas. And like I always keep telling you, Max may problem here is Max is not the problem. Converting the problem into mathematical part is a headache in physics. Clear with this? Let me show an example. So example, if someone asks you like this, x square dx from 1 to 2. So this is n is equal to 2. The formula is x power 2 plus 1 by 2 plus 1. Did I use already x square? Yes, I did use. So let's use x cubed. 3 plus 1 by 3 plus 1. Limits 1 to 2. So basically x power 4 by 4, limits 1 to 2. I still didn't put the limits. Now substitute 2 here. So 2 power 4 by 4. Then substitute 1 here, 1 by 4 by 4, and then subtract them. Put the upper limit, put the lower limit, and subtract them. So this guy would be 16 minus 1, 15 by 4. What is the meaning of this? If you take this x cube ka curve, y x graph, can you tell me how will this curve look like? How will y is equal to x cube function look like? See, this is how it goes. X is 0, what is y? 0. So it starts from origin. As x ka value is increasing, y ka value will increase. If x is negative, what is y? If x is minus 1, y is minus 1. X is this thing. So this function actually goes like this. Have a look at this. This is how the graph of y is equal to x cube looks like. When x is positive, y is positive, and x is negative, y is negative, and it is increasing faster. And you have taken limits here, x is equal to 1. And you're taking limits here, x is equal to 2. So this area is 15 by 4. This is what you have calculated. Is this making sense, everyone? This is what we are trying to do. Till now, you don't know how to calculate area under a curve. Now we know. So this formula gives you the area under the curve. No need to write it down, but have a look at this. If I show you one more example, integral root x dx 0 to 1. So this is x power half plus 1 by half plus 1. Limits will go from 0 to 1. So this would be 3 by 2. So 2 by 3, x power 3 by 2. Limits will go from 0 to 1. Substitute 2 by 3, 1 minus 0. So answer is 2 by 3. Same thing here. If you try to put this graph, y is equal to root x, the graph would look something like this. So you are asking me to find the values from 0 to 1. So this area was 2 by 3. That is the meaning of this. So now we have an ability to find area under any curve. We started from a rectangle and the story went on, and finally we reached the curve. If you remember, didn't we do something similar in differentiation? We started with a line ka slope and then we reached the tangent. All clear with this? So that's your first formula which you should remember. X power n dx. Quite common. Almost 70% of integrations in physics is based on that formula only. Next one. Integral x1 to x2, we will directly write down this thing. These are more important. Indefinite is fine. Sine ax plus b dx. You need to mug up these formulas. Minus 1 by a cos ax plus b. Limits will go from x1 to x2. So minus 1 by a, substitute the limits. First put x2, cos ax2 plus b. Then put x1 and subtract cos ax1 plus b. Please note it down. Now, how we got this, we'll not get into that part, but you can check it out. If I differentiate this, I will get this function back. What is cos ka differential? Sine minus sine. And then you have to differentiate whatever is inside. So one more a will come out. So that a and this a will cancel. That much you can figure it out. If you differentiate the answer, you should get the solution question back. Whatever is this thing, if you differentiate, you should get this answer back. That's a easy way to remember. Integral cos ax plus b dx. x1 to x2. Limits ka logic is always same. So substitute x2 ka value, substitute x1 ka value and subtract them. Be careful. There's a slight chance that you might go for differentiation integration ka problems. You'll mix up the formulas. Oh, hota hai. In my first year of teaching, I did something like that. In one batch, I was teaching integration. One batch, I was doing differentiation. In second class, I messed it up. After 10 minutes, I realized I messed up. Then I had to cancel the whole page and again start from beginning. 2011, I guess, when I was in Hyderabad. After that, I decided I will never teach differentiation integration at the same time. It's a mess. You learn these kind of small things being a teacher. There was one time, right, I was teaching thermodynamics. So in thermodynamics, physics, there's a certain convention. If you do work positive, heat, negative, karke kuch tha. No matter how many times I teach, the kids are messing it up. Every time they're messing it up. Matlab, I was like, yeah, and kids are not, ऐसा भी नहीं इतना difficult है. I was like, यार हो क्या रहा है मतलब? After teaching them for 10-15 minutes, they do it again, but then again go for once in a while. Then I got irritated. I went to the staff room. So there the chemistry sir was telling someone, ये बच्चे लोग ना, they're just messing up the sign convention. Don't know what the hell they're doing. And I heard his voice. I said like, यार chemistry वाले ऐसा क्यों बोल रहे? Then I asked him, sir, what are you teaching? He said, I'm teaching thermodynamics. So physics and chemistry, we have a thermodynamics chapter. We have a convention different. So what is plus for us is minus for them. Since both the teachers are teaching the topic at the same time, what will the students do? They're coming to physics class and using chemistry convention. They'll go to chemistry class and using physics convention. So after that, we decided chemistry and physics by thermodynamics should never be taught at the same time. So we have to be careful. Copy it up. Clear with this? Let me show an example. Turn in the page. Example, let's say someone asks you integral sine x dx. Simple one. 0 to pi by 2. Now, if you look at the formula here, sine ax plus b, a ka value is 1 and b ka value is 0. So the formula is what? Minus 1 by a cos ax plus b, 0 to 90. So a is 1. So this is basically minus cos x 0 to 90. Minus, substitute the values. This is cos 90, which is 0, and cos 0. So this is 0, minus 1, and 1. So what do you mean by this exactly? If you try to plot this on a graph, how does a sine graph look like? Sine ka graph will always lie between 0 to minus 1 to plus 1. This is how the sine ka graph looks like. This is 0. This is 90 degrees. This is pi. This is 3 pi beta. You don't need this. I'm just showing you. This is 2 pi. So the function repeats after every 360 degrees there. So 0 to pi by 2 meaning this area is 1. Are you getting what we did? Suppose if I say cos 2x dx from 0 to pi by 3. So here a is 2 and b is 0. So this is 1 by 2 sine 2x. Limits will go from pi by 3. So this will be sine 2 pi by 3 minus sine 0. Sine 120 is root 3 by 2. So this is root 3 by 4. So if you try to plot y is equal to cos 2x graph. So cos 2x graph when x is 0, y is 1. It starts from the peak value. It's like this. So this is 0. This is pi by 4 because this is 2x. The function becomes cos 90 becomes 0. You'll get cos 90 when x is pi by 4. So pi by 3 is somewhere here. This guy is pi by 2. No. This guy is pi by 2. So pi by 3 should somewhere be here. So this area and this area. The total area is 3 pi by 4. And here something nice we see. The area under x-axis is taken as negative. We will discuss about this in detail later on. If there's an area under the curve, it is taken as negative area. Have a look at the examples. Again, I'm trying to draw the graphs, but actually exam you don't need it. I'm just trying to show you a geometrical interpretation. Any doubts on this? Please ask me. Devika, clear with this? Om, Pushkal, Kanish, clear with this? Sania, clear, na? Archita, clear so far?
Yes, sir.
Aishwarya, Arush, clear? Now, next thing. Integral e power ax dx. 1 by a e power ax integral x1 to x2 limits e power ax2 minus e power ax1. Integral 1 by ax plus b. This is a very good integration. The fifth one comes a lot, but mostly start encountering this in 12th standard a lot. Be careful, dx hona chahiye. You just can't integrate a function like 1 by x. There is no meaning of this integration. This is the height into breadth. You're finding the area there. So this is 1 by a ln ax plus b. Did they teach you ln ka thing in maths? Ln a plus ln b, ln ab, ln a minus ln b. They taught you? They didn't teach? It's okay. Maths mein abhi physics mein to itna will not encounter right now. They will teach you in maths anyway. But if you know it better, just in case. So this is ln ax2 plus b minus ln ax1 plus b. Now here, if a is equal to 1 and b is equal to 0, this becomes 1 by x. This is ln x. Remember that formula n is equal to minus 1? So here, if you see, this is actually integral x power minus 1 dx. This is n is equal to minus 1. So be careful here that that first formula is not valid. This is for n not equal to minus 1. So when if n is equal to -1, we have to use ln x. This is ln x2 minus ln x1. And we have some formulas in ln. Ln a plus ln b is ln ab. Don't worry about this. Let Max will teach you. I'm just writing it down here. Later on, when you refer, at least you will have an idea. There. These are the 5 primary formulas. Actually, even though this is primary, I gave you a more important ones. Matlab, we will not do all that chain rule, gain rule stuff we don't have in this. So let's keep it simple. Do note it down. Clear, everyone? Can I go ahead? Brijesh? Clear, na? Arush? Shashwat?
Yes.
Great. Now, after this, we have 2 identities. Actually, there is a product also, but we don't need it. The first one, integral a into f of x dx, where a is a constant. So you can just push the constant outside and integrate normally. Just like differentiation. Example, if someone gives you integration 3x square dx, let's say from 0 to 1, you can just push 3 outside. This will be x square dx from 0 to 1. And the formula for this thing is x power 2 plus 1 by 2 plus 1, 0 to 1. So that would be 3 by 3, x cube 0 to 1. 3 will cancel. This is 1 cube minus 0 cube, which is 1. Right? And then the second identity, if you have a function f of x plus or minus g of x dx. So if you have 2 functions like this, you can just split them, f of x dx plus or minus integral g of x dx. Same thing we did in differentiation also. So example, if someone gives you an integration like sine x plus cos x dx, you can just integrate sine x dx separately, cos x dx separately. You can just use the appropriate formula and finish it off. That's it. These are the 2 entities and the 5 results. If you know this much, you know the basic mathematical part of integration. Have a look at this. Clear, everyone? Let's see some problems. So you note down the formulas, right? So it is just a matter of mathematical part. There's nothing much to think. So integral x cube dx.
So I couldn't write down the second formula. Could you, sir?
Write down, write down.
Yeah, okay, thank you, sir.
Let's say x square dx. Let's say it goes from 1 to 2. There. So I'll write the questions, you write the answers for that. Let's get them. First one, x cube dx. So x power 2 plus 1 by 2 plus 1. Limits will go from 1 to 2. X cube by 3. Limits will go from 1 to 2. So that is 2 cube. Later on, we're going to skip the steps. That's 7 by 3. This is integral x power minus half dx. So x power minus half plus 1 minus half plus 1, 0 to 1. That is 2 root x 0 to 1 to 1 minus 0 2. How do the third one? शाश्वत लिमिट्स है x का वैल्यू आएगा नहीं. When there is a limits on the top, you'll never get x in the answer. The final thing should be a number. Third one कैसा करेंगे? It is x square plus 1 का whole square dx. Now, there is no chain rule ना. Don't say something to the power of 2 something, ऐसा कुछ नहीं है. Expand ना a plus b whole square. Then you'll get 3 terms. Then एक एक term को integrate करो. Try. I'll give you a minute more. Hmm. 11 by 5. Anyone got 11 by 5 for third one? Try. Just give it a try. I'll get some water and come. 13 by 5, 28 by 15, 11 by 5. Nothing is matching. 28 by 15. Let's see. So expand this. X power 4 plus 2x square plus 1 dx. Limits will go from 0 to 1. So x power 4 ka integral is x power 4 plus 1 by 4 plus 1, x power 5 by 5. I'm writing directly now. 2 x square dx is x cube by 3 plus 1 dx is x only. Maybe I'll put it on more detailed weight. X power 4 dx plus 2 times x square dx plus 1 into dx can be written as x power 0 into dx. Make sense? 1 is x power 0, no? So now if you apply the formula here, this is x power 5 by 5, limits 0 to 1, 2, that is x cubed by 3, 0 to 1, x power 0 plus 1, plus by 0 plus 1, 0 to 1. Basically, it is x only. This is 1 by 5 minus 0. This is 2 by 3 minus 0. When you put 1, you get that, and this is 1 minus 0. So this is 1 by 5 plus 2 by 3 plus 1. How much is this? 3 plus 1, 5 by 3, 5 by 3, 1 by 5. 5, 15, 20 by 15, no. 28 by 15. Please check your answers. So integral dx is x only. Keep that in mind. Basically, you can write it as 1 into dx, which is x power 0 into that. What about the third one? Third is easy. 3 times integral x dx plus x square dx. So this is 3x square by 2. X cubed by 3. That is 3 by 2 plus 1 by 3. Yeah, right, Shashwat. Have a look at this, everyone. I hope this is making sense. Any doubts on this page? Anyone not convinced with anything particular? Please ask me. Let's see a few more. In integration, right, there is also something called a product rule is there, but we don't require for physics. So don't worry about learning right now. Let them teach you in 12th standard. Never comes in physics. Let's get this. Fifth one, see. So this formula, right, is sin ax plus b, a is equal to 2 and b is equal to 0. The formula is 1 by a cos ax plus b. You need to get used to this. So minus 1 by 2. So take that minus outside. This will be cos 2 pi by 6 is cos pi by 3. That is cos 60 minus cos 0. This is minus half. Cos 60 is half and cos 0 is 1. So that is minus half. Minus half is 1 by 4. Yeah. Check the fifth one. Try. Devansh, ho gaya sab? Do focus on the class. If you're so busy, you have something important to do, then I think you can leave the class and go, and then you can come back once you're done. Let's see the sixth one. A is equal to 3, B is equal to 0. The formula is 1 by A sin AX plus B. So 1 by 3 sin 3x 0 to pi by 3. So when you put pi by 3, you get sin pi, which is sin 180, and sin 0. Both are 0 actually. Let's try to understand the meaning of this 0. Why are we getting 0 here? This is what I was talking about. If you plot this graph, this was pi by 6. This was pi by 3. This is a positive area. So area above the x-axis is positive. This area is negative area. Therefore, area from 0 to pi by 3 becomes 0. That is a convention. Because see now, when you're in the up, this is positive y, this is positive x. So area is plus y into plus x. If you go down, it is minus y and plus x. So area is minus y into x. You're getting it? So the area actually becomes negative. Then there is a meaning for negative area. We'll see later on. So here, if you see the total area up to pi by 3 is 0 because they cancel out. How to do 7th and 8th? So if you think like area 0 kaisa ho sakta hai, the meaning is that there is a area above the x-axis and there is a area below the x-axis. See, we call it area, right? But Max doesn't know what is y dx. Max doesn't know y dx is area. It is you and I who is calling it area. For Max, it is simply an integral. Max doesn't give a damn like what we think about it. What about 7? Sin x plus cos x ka whole square. pi by 2 plus 1. 0 तो नहीं है. Pi by 2 plus 1, something like that you get. Try it. I'll give another 30 seconds and I'll show you. Just expand it, na. Sin square x plus cos square x 1 हो जाएगा. Then you'll get 2 sin x cos x. What is 2 sin x cos x? Sin 2x. So the trigonometry, remember in the beginning I taught you? That will pop up now. In case you forgot, that is the first thing that we did in the first class. There, these are the formulas. Sin 2 theta is 2 sin theta cos theta. Cos square theta, sin square theta. These things will come now. In case you forgot, you can write it down right now. The two things in the red box are literally important. You will see them at least 10 times or 12 times in physics. Sin 2 theta is 2 sin theta cos theta, and cos square theta is 1 plus cos 2 theta by 2, and 1 minus cos 2 theta is sin square theta. Clear? Now try. Let's see. So integral sin x plus cos x ka whole square dx. Limits are 0 to 90. So expand this, you end up with sin square x. Cos square x2 sin x cos x. Sin square cos square x is 1, and 2 sin x cos x is sin 2x. So this would be integral dx plus integral. So dx ka integral is x only. Sin 2x ka integral is minus half cos 2x. Now you should get used to this thing. Limits will go from 0 to 90. This is pi by 2 minus 0. Minus half cos 2x is cos pi minus cos 0. This is pi by 2 minus half, and this is minus 1. That is minus 1, that is minus 2. So pi by 2 plus 1. Check. Yeah, right, Devansh. You got an answer. Shashwat, you got it. Arush, you got it. Pi by 4 for 8 देखते हैं. Have a look at the seventh one. What is 8th? Integral sin square x dx. Integral sin square x dx 0 to pi by 2. That's your 8th one. Try. I'll give a minute. Quite an important integration. Huh? Sin square x and cos square x integration will come a lot. Eighth one, any more answers? We have one answer, which is 5/4. Hmm, 5/4. Let's see. So sine square ka integration, right? The problem is there is no way to integrate this. So sine square x can be written as 1 minus cos 2x/2. You should know this result. So the RAF comes out integral dx minus integral cos 2x. 0 to pi/2 and 0 to pi/2. This is pi/2 minus 1/2 sine 2x. 0 to pi/2. This is pi/2 minus half sine 180 is 0. That is also 0. Pi/4. There. Try this also, integral cos square x dx. Let's get these two. What is the answer for this ninth one? It will be actually the same one. Ninth one, we put for cos square x. Remember, cos square x is 1 plus cos 2x/2. So that's what I said. You need to know these formulas. Others, do keep your cams on. So this half comes out. We have integral dx. This is pi by 2, and that is 1 by 2 sine 2x 0 to pi by 2. That again comes out to be 0. The same answer. The reason you get the same answer is because if you actually plot the graphs, you'll notice something. Y is equal to sine square x. Y is equal to cos square x. The sine square x graph looks like this. It's all positive. Cos square x graph looks like this. So when you say 0 to pi by 2, you are finding this area. Here, this is 90. You're finding this area. It is the same area, isn't it? It's still half only. It is the same area. It doesn't matter. That's why you're getting the answer same. So even though the answer looks same, doesn't mean they're exactly identical. This is a catch. What about the last one there? E power minus 2x. This was easy. This is a is equal to minus 2x. So the formula is 1 by a e power ax. So 1 by minus 2 e power minus 2x, limits 0 to 1. So minus of e power minus 2 e power 0. Be careful, e power 0 is 1. So minus of 1 by e square minus 1. Send minus inside. 1 by 2. 1 minus 1 by e square. You can leave the answer like that. Clear with this. Now, this is one way of asking questions. They'll just give you the formula and put it there, but let's see. All clear with this? Any doubts on these 10 questions, please ask. Now, let me show you another way of framing a question. They'll ask you like this. Find the area enclosed by. Again, this is not really a physics one, but just for one idea there. Y is equal to x and y is equal to x squared. They'll ask you like this. What am I exactly asking here? Let me help you out. So if you try to draw the graph, y is equal to x is a straight line. Y is equal to x square is a parabola. Area enclosed by between means I'm asking this area. How will you find that? Think for a minute. 2x cube minus 3x square. Now, let's try to understand, okay? So what is being asked here is this. Let's take them separately out. So can I say like this? This is y is equal to x. Now, what is this point of intersection? So this point is 0, 0. When x is 0, y is 0. This point is 1, 1. Agreed? Because when they intersect, at that point, both x and y coordinates are same. So indirectly, what I'm asking is, if I can find the area from x is equal to 0 to 1, that will be this area, minus if I can find the area under the parabola from here. If I subtract this area minus this area, won't I get this area in the middle? Is that logic making sense? I will find all the area below this and I'll find all the area below this. If I subtract them, I'll get the area between them. So you're done. So this thing, so A1 is integral. What is area under the curve? Y dx. But y is x only here. Limits are from 0 to 1. So this is x square by 2. 0 to 1, this is half. Let this area be A2. This is y dx is x square dx. So same thing basically. I'm just putting it in verbal form. Find the area under the curve. Karke. So this guy would be x cubed by 3. Limits will go from 0 to 1. This is 1 by 3. So this area enclosed will be is the area under the line minus area under the curve. So half minus 1 by 3 to 1 by 6. Please check the logic there. Is the logic making sense? I will find all the area under the straight line. So this is the line. I'll find all this area, the black line. I'll find all the area under this curve. Let's call this thing with some other color. Let's say green maybe. So if I subtract the black area minus green area, I'll be left out with this red area there. So just have an idea. These questions can be framed like this also. Is everyone clear with the steps? Any doubts on this? Please ask me. So there, that is one level of integration. So like integration, they really don't ask more than this. If you know this much, this is sufficient for 11th and 12th physics. But then, like I keep saying, questions won't come like this. So the most important one is finding applications, which we will do in the next class. And then in the other class, we'll be doing applications of integration in kinematics. Acceleration is given, find velocity, velocity is given, find position, all those kind of things. So we will be going for another 2 classes, we'll go for this. But we are actually finishing off all kinematics ka integration and differentiation based problems here. So it works out. I think by next week we should wrap it up and then we'll start off with kinematics. Calculus is over in your classes? Placement is done. But others it is still going on. Okay. So with that we'll wrap up for the day. So I hope today's exam is deadline is still 10:30. Make sure to give it, finish it off. That is one.